So we want to look at the techniques of differentiation, and the first one is function of function. So how to find the derivative of a function of another function. So let's take for example, um, identify a function of function first. Okay, how do you identify a function of function? Suppose we have suppose sine, we have y equals sine open bracket x squared plus 5. If you look at this function that we have here, you will see that another function has been embedded into a particular function, right? Good. What we used to know is sine x, but now we are not seeing ordinary sine x again. We are now seeing sine of x squared plus 5, and x squared plus 5 is another function on its own. You understand now? So we can say that let a variable u denote x squared plus 5. So which implies that our y now will now be sine u. Okay, now this one look like what we know, sine x. Now sine u, then our u is x squared plus 5. Okay, how do we now find the derivative of function like this? So first we say that we recall that dy dx will be dy du times du dx. So look at, if du cancel du, then it will give you back dy dx. Okay, so meaning that in this we need to differentiate y with respect to u, and also differentiate u with respect to what? X. So let's differentiate u with respect to, that will give you du dx is equals to, differentiate this now, what we have done now. So we just be applying them. So what's the derivative of this one? What's the derivative of this one? 2x. Differentiate this one is 2x. Differentiate this one is 0. So that is just 2x. So we have 2x. Then the derivative of y with respect to u. So we have dy du. We give you from the standard derivative that you have. That is, by the time you begin to use them, you get used to them. Cos u. So in this case, it means cos u. Okay. So that's what you need. Then you just substitute into this formula. Okay. So we now have that dy dx will equals to dy du, which is what? Cos u multiplied by, okay, 2x, right? So, and if you try to multiply these two, you can multiply it so that it looks beautiful as 2u cos u. But remember that it must be a function of x. You will now replace the value of u that you, so that it will now become 2x cos x squared plus 5. That is it. That is function of function. So let's take another example on the function of function. Suppose y equals to exponential sine x. Exponential sine x. So which function has been inserted into another function? Which function has been inserted, or sine x, okay, into which function? Exponential what? Exponential x. Good. So it means that we have one exponential x before, but sine x now replacing that x. Good. So we say that let u equals to the one that has been inserted, okay, so that y will now become exponential u. So is it clear? So we just follow that definition. Don't forget that we need the derivative of u with respect to x, and that is the derivative of u with respect to x is cos x. Beautiful. Cos x. Now we need the derivative of y with respect to u. That will still remain e raised by u. Okay, raised by u. So we now apply that formula that dy dx is equals to the, if you wish, you can say du dx times dy du. It's still the same thing. Okay, so du dx now is cos x multiplied by dy du, and that is exponential u. Okay, so multiplying these two together, we're going to have cos x exponential u. Replacing the value of u, we're going to have cos x exponential sine x. Replacing the value of u, we have that. So let's see what you're going to do with this. We have to solve this. The derivative. Okay, first we look at the function that has been embedded into another function. Okay, what function was embedded? X squared. So we see that let u equals what? X squared. So that y will become cos u. Excellent. Excellent. So we now have to find the derivative of u with respect to x. What would that give us? 2x. Beautiful. What's the derivative of y with respect to u? Minus sine u. Excellent. Minus sine u. Okay. So we now use our formula. which means that dy dx will be equals to du dx, right? Which is 2x multiplied by minus sine u. Excellent. So we just multiply and replace the value of u. That should be minus 2x, I mean, because of the minus here, sine the value of u, which is just x squared, and that is it. Alright, so let's quickly discuss the shortcut. Now, anytime you have been able to observe that you are having a function of function, you have to be sure first that another function has been embedded into the other one. So the first thing you do is differentiate the one that has been embedded, get the result. Then before you now differentiate the original function itself. So let's say we observe that sine has been embedded here, right? So differentiate this one first. That gives us, so we just say that dy dx will be equal to differentiating sine, that gives us cos x multiplied by, now you not differentiate exponential. You know, exponential will still give you exponential. So that will just be multiplied by exponential, whatever that you have there. Okay, and that's the solution. Where's it? That's the solution there. Okay, so let's look at this one. We know that x squared has been inserted, right? So differentiate that x squared first. That will be 2x multiplied by, now differentiate cos. Anytime you're going to have minus sine, anything you have in front of it will still be there. Okay, so if you multiply this, you get what we have here, which is minus 2x sine x squared. Okay, so we have 4x replacing x in x to the power 6. So what we now do is, following the shortcut now, dy dx will be, we differentiate the one that has been embedded first. So if you differentiate 4x minus 5, what would that give you? 4. Beautiful. Times, now you will now differentiate this, taking it as just one single entity with the power 6. You now differentiate that. So what would that give us? 6 will be coming down, right? The power will be coming down, right? We are taking this one as just one single x now. So we have open brackets 4x minus 5. Then what do we do to the power? We minus 1, Abi. Okay, good. And that is our solution. So we just need to simplify this. So we now have 24 open brackets 4x minus 5 raised to power 5. And that's it. So we observe that 3 minus x is replacing x in exponential x, right? So using our shortcuts, dy dx will be equal to, find the derivative of the power. What would that be? Minus 1. Excellent. Minus 1 multiplied by, now the derivative of this one is still exponential, right? Exponential 3 minus x, and that's all. So the solution is just minus exponential 3 minus x. Just here. Okay. Let's look at the solution to the exercise. We have y to be equal to exponential sine 2x. Okay, so using our shortcut, so dy dx will be the derivative of sine 2x, which is 2 cos 2x, multiplied by the derivative of exponential, which is exponential sine 2x. Okay, so the result of this will be 2 cos 2x exponential sine 2x. Okay, so the second one, we have y to be equal to sine squared x. So the meaning of this is that y is equals to sine x all squared, sine x squared. Okay, so if we apply the chain rule to this, using the shortcut, differentiate what we have inside, that will give us cos x multiplied by, we now differentiate this, taking sine x as a single value like x. Okay, so we now have 2 sine x, then 2 minus 1 will now be the power now, which is still 1. Okay, so as we simplify this, we have 2 sine x cos x. From our knowledge of MET 101, so we have that this is equal to sine 2x. To lean cos 3x and want to find the derivative, so we have that dy dx will be equal to the derivative of cos 3x, that will be 3 minus sine 3x. So that means we have minus 3 sine 3x. Now multiply by the derivative of ln, that is 1 over cos 3x. Okay, so if we simplify this, what we're going to have minus 3 sine 3x divided by cos 3x. Okay, so we observe that we're having sine 3x over cos 3x, and that is tan 3x. So our result will be minus tan 3x. So the next one, number 4, we have y is equal to y equals cos cube 3x. Okay, this means we have cos 3x all raised to the power of 3. So the derivative will be the derivative of cos 3x, that will be minus 3 sine 3x. Then we now differentiate this, taking this as a single entity, that will be multiplied by 3, then cos 3x raised to the power of 2. If we put this together, we're going to have minus 9. Minus 3 times 3 is minus 9. Then we have sine 3x. And then cos 3x squared is the same thing as cos squared 3x. We have y equals to ln 3 minus 4 cos 5x. So also we differentiate the inner function. So we have that dy dx will be equal to differentiating 3, that's 0, differentiating minus 4 cos 5x, that will give us minus 4 is waiting, multiplied by minus 5 sine 5x. Okay, so that is the result of the derivative of this. Now multiply by the derivative of ln, that will be 1 over 3 minus 4 cos 5x. Okay, so here we now have minus 4 times minus 5, that is 20 sine 5x divided by 3 minus 4 cos 5x. Okay.